Hi, welcome to this particular subject, which is Operational Technology Security. We're going to cover Lecture 1 today on this particular subject. So, Lecture 1, we're going to cover this thing called differences in deployment of industrial control systems. Okay. So, what is the subject? Operational Technology, OT, okay, security. So, this is the Lecture 1. So before we start anything, the whole training itself will cover basically cyber security as it is. So very important when we are covering cyber security end of the day, right? You will cover some of the hands-on training end of the day, right? This is basically this hands-on training basically allows the student to gain necessary skill set and knowledge to take a look at whatever possible cyber attack is. But all these things is done in a safe environment, ethical manner. Okay, that's why it's called ethical hacking end of the day. Okay, and it's all in the sandbox. It is important that students understand that any unauthorized access to data, computer or network system is a crime by many jurisdictions, including Singapore end of the day. Okay, so there's a Computer Misuse Act. Okay, so whatever you learn here, it is important to help you in terms of doing defense. Okay, so the key word is to do defense. Okay, end of the day. So it's not for you to use it to do harming for someone. Okay, it is end of the day learner's responsibility end of the day. Okay, that or whatever it is using, it is compliant to the computer law, okay, for Singapore especially. Okay, next. So that's the first most important thing that we cover. Next, so we're going to cover some overview, right? Before we continue to do that, let's watch a video.
If you're an IT professional, why should you take this course? This course will help you understand how you can use your tools and skills to protect the control system environment of your organization. If you're a control system engineer or operator, why should you take this course? We developed this course so that you can start to understand the skills, the capabilities, and the tools that are available on the enterprise side of your organization to help protect your control system environment.
Okay, next, basically we're going to go through the learning objective. Okay, first of all, define what is a industrial control system, basically over here. Okay, recognize what are the importance in terms of cybersecurity for the ICS, the importance in terms of cybersecurity. Okay, and then look into critical infrastructure sectors. Okay, what is critical infrastructure, why they are important. Okay, and then different type of facility that supports critical infrastructure. Okay, and last but not least, the different type of industrial processes, okay, and their dependencies. Okay, so these are some of the things that we will cover in this chapter itself. Okay, so let's take a look at what is an industrial control system. Okay, industrial control system as a whole, very simply, it is a facility, it is a system, it is a piece of equipment. So it can be a place, a large facility, it's a system, very complicated, many things that connect together. It can be a room size or whatever. It can be an individual component, so it's every single one of them. It is comprised of, basically it allows you to control the environment. Example, as big as electrical system, water system, so you can control the environment end of the day. Okay, of course, it also can do your HVAC, basically your aircon or your heater system. Okay, it provides some form of services. End of the day, your water services, your electrical services. There's some form of diagnostic that need to be done by engineers. End of the day, okay. Because if this thing goes wrong, someone have to go there and do troubleshooting and look at the equipment and bring it up again. It has some functional capability, okay, that allows to create certain things. So in many areas, one of the key area is example for hospital or pharmaceutical environment. So it's also will include aircon, but also the manufacturing of the medication, or sometimes you provide hospital service to patient, day, right? So you have some form of diagnostic equipment. So if for the doctor and nurse, you have some equipment that you diagnose the patient as a whole, what kind of information about the patient itself. And then there are some functional capability allows the patient to do operation and whatever the doctor, right? The operation room, okay? It need to be effective and reliable in terms of automation, okay? ICS is an interconnection of component. Number one, command, okay? Okay, first of all, it is an interconnection. It connects many things together to provide command or direct or regulate itself to another system. So it can command some other system, it can direct some other system. It means two different things. Okay, basically direct means that there are some motion in. Command maybe just turn on and turn off, right? And regulate itself, okay, and be able to have a feedback information for that. Okay, so the whole process can be a single factory or a single pharmaceutical, make medication or whatever, or can be a hospital. Okay, it can be distributed over a large geographical area, end of the day. Okay, next. So different type of industrial control system. Okay, so it can be a supervisory control acquisition system called SCADA. Okay, this is a traditional one. When you go into manufacturing, electrical system, water system, it is all SCADA. Next thing is a distributed control system, mainly for large utility like electrical system. They typically comes with DCS. It's a very powerful computer. Okay, for smaller place, example, pharmaceutical company, most of the time they have a process control system. Okay, DCS a lot of time are more meant for the higher power for electricity to generate electricity. Then energy management system also for electricity. So this one is mainly for electrical plant. Okay, plant. Okay, same. This is also electrical plant. Okay, next thing is the automation system that allows you to automate some of the process. Okay, that's involved in terms of processing all the various things. Next one is a safety instrument system that this appear in many places. This also appear in many places. Smaller area, they have automate, allow you to have robot that come in and do all the necessary process. The robot may not be just robot arm, it can be some machineries that create, for example, pharmaceutical company do some of the thing. In hospital, it may be for automation. End of the day, it may be certain things that help to allow a patient to survive. You automate, for example, the oxygen. For example, your during COVID, right? Okay, so there's a lot of oxygen machine. Right, automatically pump the oxygen to the patient itself. Right. Then you have safety system. Safety system a lot of time happen in a factory. Okay, because there are maybe a light industry or heavy industry or even pharmaceutical company, you need to have an emergency stop. Okay, so this is when the easiest one is emergency stop. We call them e-stop. Okay, so e-stop portion, this emergency stop, end of the day, allows you to stop the whole entire thing in case you see something that may kill someone or hurt someone, end of the day. Okay, and then there are some other or automated control systems such as HVAC, your aircon and heater. Okay, next. So what are the use? Okay, it is a process. Okay, it is a process and a series of steps to achieve some of a process is a series of steps. So there is a thing called, for example, purification of water, landing of aircraft, and for your particular course tilting chemical, because you end of the day want to create some pharmaceutical company, want to make some medication, or it is a process that end of the day that involve in terms of providing a patient some services end of the day, helping a patient to recover, so you may have some drips to the patient itself. So these are some of the usage for the ICS. And of course there are the other part, which is the sensor part that monitor the patient heartbeat and so on and so forth. Okay, and ICS have components that are common, okay, that typically are very common to control all the processes. Okay, sometimes there are differences, okay, because the same component may be used for different purposes in the ICS implementation. Okay, so the same, basically, if you think in terms of that, CPU can be used to process different things. It can do some form of calculation, whether it's for water, it is for electricity, or whatever not, right? The same kind of processor, but at the end of the day, whatever it is used for, it can be used for different things. So the example is to shut off certain product flow to a vessel base where the product level has reached. So you have a boiler that actually do these things, okay? That actually automatically switch off when a thing hits to a particular level. So example, a pharmaceutical company, there's certain liquid that they do, it reaches a certain level, it will switch off. The other one can be used for weighing, can be used for calculation, and for some of the flows, right, for controls. So each method has their own advantage and disadvantage based on the cost, the safety, and the environmental impact end of the day. And last but not least, the product quality that you have to achieve. So ICS can be used and it can be implemented differently end of the day for different process, depend on what it is used for. Okay, for most of the ICS system, okay, they are mainly, most of them are critical systems. Okay, so therefore availability is very important. You need to make sure that end of the day they can be accessible, they will be able to be operational end of the day. Example, you have patients, right? So at the end of the day, it's important that the oxygen is provided to the patient, or else you have an issue end of the day, the person may die end of the day. Okay, so next thing is physical security is one of the critical concern for a very long time. You don't want the hospital or the pharmaceutical organization, someone you don't know who is it, went into the hospital or pharmaceutical organization, end of the day cause a huge chaos for it, right? So it was a very, very important thing. It is still a very important thing today, okay, for one of the primary concern, right? For a long time, because of that, right, cyber security was not the main concern, was not the problem, because they're never connected to anywhere, not connected to the internet or whatever, right? But today, as there is a requirement, right? Example, from, let's say you have a hospital that has no doctor, right? End of the day to do operation for a certain operation. So you want to have a remote access, be able to do the operate, because you cannot possibly send a person to fly several hours or take several hours off, which is very remote end of the day. So there is some things such as remote access, which is important for connectivity, for example, to treat a patient which is remote, okay, or to create using some form of standard, for example, using normal the typical internet, right? By doing that, right, you're creating some form of, because internet, when you have interconnectivity and all this sort of thing, there are new weaknesses found, okay, created, okay, all these are new weaknesses, okay, because it never appeared before. So all weaknesses is vulnerability. Vulnerability are weaknesses, okay, and it may not be so easily be removed because of the nature of the way all these standard protocol is being designed, all these standard networks been designed. Okay, next. Okay, so on this part, it is not so trivial to actually to apply whatever you use for traditional IT system into ICS, because it is traditionally designed just for IT system, right? If you want to specifically use it for ICS, it is very challenging, okay, because they are designed very differently, because previously they are isolated system, right? Your IT system is an IT system. Your ICS system is an ICS system. Your ICS system is basically isolated. Isolated. Okay. Now you're trying to apply whatever over here, and then for on top of that, you want to have physical security, you want to have availability and whatever, plus whatever you've done here, and then you try to hard fit into here. It is very challenging end of the day. Okay. It is possible, but then it is very challenging. So end of the day, people try not to do that. People try to think of a new way of how to do protection for ICS. Okay, so we are going to move into objective 2 to recognize the importance, okay, of cybersecurity in ICS. So we actually look into some of the case that happen for cybersecurity in ICS. So if you take a look into this context, there is a lot of attack on cyber attack on ICS system. These ICS systems typically support a lot of critical infrastructure today. Okay, that is which is a big issue. Okay, every day, almost every day, they disclose about some form of weaknesses of this basically ICS system. Okay, so these weaknesses are important, and then we need to deal with it and then do all the necessary patches. Okay, some of these things basically support national economy well-being. Okay, of course some of them go further than that. It deals with has to do with everyday you and me in terms of the human life. Okay, if you talk about pharmaceutical organization or even healthcare systems. Okay, so CSA, which is our cyber security agency, cyber security agency, okay, is one of the very important thing that they deal with. They do all the basically the rules and regulation for cybersecurity for Singapore. Okay, stress that it is very important that cybersecurity is related to cyber critical infrastructure. We will look into some of the document that later that they will go and cover by cybersecurity agency in later part of the lecture. Okay, that a lot of today there is a lot of foreign country that target Singapore ICS systems. Okay, and constantly we need to monitor our critical infrastructure, and that's why they have come out a piece of document that lay down their altogether 14 critical infrastructure that different sector that we are covering on. So we take a look at some of the example there upcoming. Okay, so one of the example of the issue. Okay, so there was some Iranian attack. Okay, attack that actually attacked Atlanta, Georgia. Okay, using some malware and then locked out some of the city service and demand for 51,000 ransom for the ransom based on the system itself. Okay, the cyber attack has been not a very long week-long impact, but then cost the city a lot of money, which is $7.2 million. Okay, next one, there's a second one, which is 2018. Italian oil and gas services was being targeted, okay, by another malware called SHA-Mu3, and then it impact other servers in the Middle East, such as Saudi Arabia, United Arab Emirates, and Kuwait. Okay, along with some of the other devices in India and Scotland. So you can see it's international, it's covered a big area. Okay, and all these things deal with gas and oil and gas services. So it's very scary end of the day. So if it's explode, someone may kill along the side. Okay, and then the malware basically wipe off files from 300 to 400 servers end of the day from 100 PCs. Okay, so the antivirus look at it, and this is the McAfee. McAfee is the company, the antivirus company. Look at it, and it seems against some of these things is against oil, gas, telco, energy, and government agency. So it's very scary, some of these issues that people are looking at. Next, there's an email compromise, okay, by this Lithuania cyber scam, okay, by two US-based multinational tech firm to wire into his account, and at the end of the day lost, okay, because he scam and he lost 100 mil. Okay, from the tech firm. The tech firm actually lost 100 million end of the day. Okay, the scammer is actually from this Lavia, okay, which is the same name as a legitimate Asian company. So they send to this invoice, and and then the all the system from all these countries are affected, the bank account. Okay, so businesses actually are affected through emails. Next one is Startnet. Startnet is a very well-known things that actually happened to Iran. So there was a USB thumb drive that was actually dropped at somewhere near there. The engineer think that, oh, you know, it's a thumb drive. At that point in time, thumb drive is pretty expensive. So there was a thumb drive that has some bad program plugged into the PLC. The engineer think that, oh, I got some storage device interesting. They didn't know that thing actually end of the day slow down the nuclear power station, the fan that do the nuclear power station. So it caused a problem to the nuclear power station anyway. So that is the Startnet that actually that's where a lot of people get worried about ICS cybersecurity, because it is a nuclear power station, okay, and it may kill a lot of people. Next thing is Tritron. Tritron is in Saudi Arabia. It is a malware that control the safety system. So that is also very things of very careful. We need to think about it, because if the safety system is not taken care of well, it may kill someone end of the day. Okay, Tritron is a system that has been discovered by some other system, and then is able to avoid detection by antivirus software. So when they do it, is during the one of the system that in 2014 end of the day. Okay. And so there is very important that everyone should be stay informed. So there is this thing called Repository of Industry Security Incident, RISI. Okay, it's a database. It's open source. People can report to this RISI. Okay, the problem that they suggest is getting more and more not just in US, but just now what you see many countries. Italian, gas and oil, can be India, can be anywhere around the world. So this is a database that actually you can go and take a look if you're interested on. Okay, and then there are some other database such as CISA US CERT, National Vulnerability Database, CVE, which is what we call them the CVE in short CVEs very common. Okay, and then the last one is the emergency response team. In Singapore, you can go to CSA webpage and take a look. Okay, CSA also has some of these vulnerability report during in their webpage itself. Okay, next we shall go into Objective 3. Objective 3 describe the critical infrastructure and their importance. Okay, some of these sectors. So some of these ICS they have dependency with one another. Okay, a water system and electrical system, they actually have dependency with one another. Okay, so failure in the electrical sector, okay, if it's an ICS failure, may cause some other sector to have that depend on electrical system and have some issue. For example, let's say you have a EV system, okay, electrical vehicle system, that actually if there's some issue with it, it will cause some other sector, for example, whether it is transport, if it's communication, or is it water. Because for water to filtration, you need to have electricity end of the day. Okay, vice versa. In order to generate electricity, right, nowadays in Singapore, especially Singapore, we are burning fuel. We burn fuel, but somehow or other, when you reach to a certain point, we need to cool down the system so that the electricity will form properly end of the day. So there are dependencies between electrical systems, okay, and water system. The water will supply to cool down the electricity. The electricity is needed to have the make sure that you have clean water and do the filtration and then do a proper work. So they are independent with one another. So that's the key portion. So next, we'll Next, we're going to see some video on this, okay, about this interdependency.
This diagram depicts the interdependencies between sectors. These sectors are tied together because of their ability to communicate via networks. Many utilities and municipalities assume that their networks are completely isolated and their employees are trusted and work responsibly. However, we have seen examples where malware and other types of viruses have been introduced to these trusted environments and spread quickly due to the way the operational networks were deployed. Thus, we should be concerned about the possibility of viruses and malware making their way into the computer systems that run these critical operations. Their impact could affect the performance and availability of the devices that control water quality, energy distribution, and government communications.
Okay, so just now you saw about the video, right? So in US, there was a point in 2003, there was a blackout. Okay, there's an example of a sector independence. Okay, so what happened? It actually affects 55 million people in Canada and US. Okay, so there are quite a lot of research about people looking into that portion. So that's the impact area. That's the size of the places that was impacted. Okay, so what happened was for power, for electricity, okay, there was a fluctuation in the power grid itself. Okay, there's a power fluctuation in the power grid. Okay, the power plant basically go to a safe mode to prevent damages from the overload. Okay, this is what actually most of the nuclear power station actually do when they're covered. Okay, at that point in time, there are hydroelectric plant that actually runs will actually came onto online and bring some of the area to have some form of electricity. Okay, until August 15. So there are many houses and businesses also affected because of the lack of electricity at that point in time. Okay, then water supply, certain area after the lack of power, that's a very important thing. Just I mentioned, right? Lack of power, right? There is a loss of water pressure on the lack of power. That reach to that cause to a certain point that certain water is being contaminated. Okay, so you're drinking the water end of the day, right? So EDCC is important. So 4 million customers in 8 countries, counties in Deloitte, water system are having this issue until August 18, 4 days after the initial outage. There is no electricity and the water is being having an issue. Then one of the county, there are 2,300 restaurants is being closed. So from electricity to water, because the water is contaminated, right? There are 20 people living in a certain area, and then it was reported sick and all that. Okay, because of bathing in the river because of the blackout. Okay, the accident because of there is a 300 plus pound of chlorine goes into the water in the chemical plant that goes to the river, and then it was not found under 5 days later. So one of the key impact is that. Next thing, another different place also lost the water pressure end of the day. Okay, and there are some sewage spill into the waterway, which is quite bad because it goes to the natural water and require the beach to close. Okay, so that is in New York City. Okay, and then there are also a big experience in terms of the spill in various other rivers that flow into the Atlantic Ocean, and the other places like Oriental lost the power of the sewage pump because a lot of your wastewater end of the day becomes an issue for a lot of places, and every places are getting very very smelly end of the day. So that is from electricity to water. Next thing, at the same time, because there's loss of electricity, the railway system is being stopped. Okay, and then there are a lot of places has been shut down. Okay, so this is an issue lah. Okay, you see from electricity to water, electricity to railway. Okay, and for airport, okay, next thing is airport, right? Where's my mouse? Okay, the airport, there are many flights that's been cancelled because there is no way they can properly, because for an aeroplane to take off, they need to have the radar on the ground itself, the people need to be able to see which plane can take off, which plane can land safely and all the day. So transportation is been affected greatly because of the loss of electricity. Of course, there are some additional, a lot of other things along the way that if you see over here, right, whatever, not just US, the Canada and Vancouver and what's so not are being affected. So then, next thing is the gas station. Many gas stations are not be able to pump. Okay, you don't think that gas don't require electricity? They require electricity to do the pumping because the pump is run by electricity end of the day. So a lot of vehicle cannot move. A lot of truck cannot even move, right? Even car cannot move. In US, they're highly dependent on their car and dependent on truck. End of the day, they don't have railway, and railway have a problem also because of lack of electricity. So from one of electricity problem, it results in a lot of other things. Okay. Next, communication. A lot of cell phone connectivity is being disrupted. End of the day, you cannot make phone call if there's an emergency. So many places in our millions of people home cannot use the phone. Okay, because there are too many people cannot use the cell phone. They're going to change to other phones, and then becomes what you call it, overwhelming of traffic, and then cause another set of problem. And the other side also be locked out because of too many people are trying to call. Okay, then the next thing is the cable TV. Cable TV actually are supposed to provide the television on news, health, and all this warning thing, but it cannot go through. So internet, a lot of internet has been disconnected end of the day. So all these are issues. You just imagine one electricity can impact so many other things. So it becomes a very, very important that end of the day, we need to keep the electricity running everywhere. End of the day, we are very, very, very reliant on electricity for today. Okay, the blackout also is also there are a lot of other things such as internet edition of the newspaper, right? Such as whatever news and Oriental are all gone for a few days, right? The thing is a lot of self-using, a lot of amateur radio in US. They have all this sort of thing that they leave off the grid. There's a thing that a lot of saying they want to leave off the grid. Okay, but a lot of times they still inside the power grid itself. So they actually have their own independent source for emergency. So all these are important for today, right? So for any society today, they need to have a certain backup plan. If there is a loss of electricity, what should people do, right? Then how about factories? There are a lot of factories being closed, okay? And then they're forced to slow down or close their work, okay, because of that, right? And then there are 7 hours of wait for the truck to cross the bridge end of the day, because the bridge is using electronic border check. So because it's not working anymore, no electricity, so end of the day, everything turned to manual. Okay. So we are going into moving to objective 4. Recognize the facility that support critical infrastructure. We're going to look at some of the facility. So what are different type of facility for critical infrastructure? Number 1, there's a thing called site. Second thing, there's a thing called transmission. Third thing, there's a thing called generation. The last thing is called distribution. So site is like, for example, you have an electrical plant. So that is the actual site that we're going to have. Or it may not be just electrical plant. It may be a water plant. It may be a hospital. It may be a pharmaceutical organization. Okay, so it can be a factory or whatsoever not. Okay, for a site, that's a particular thing that is physically that's a site. Transmission is rather not really a site. So it's along the road or along various places. So a transmission can be a gas pipeline, okay, it can be a water pipeline, okay, it can be an electricity grid. Okay, so all these are transmission. In between, they may have something what we call them the substation. Okay, and then all these substation is important. It will impact if someone or some of this thing is run by computers, and then if they been hacked, then it becomes a lot of issues, and they are very remote. Okay, for big countries. In Singapore, we don't have so many of these, but they do have, for example, every few HDB block underneath there is some substation for electricity. Okay, for water and gas, not really lah, because we are such a small country. Okay, then the other part is generation. Generate, for example, water and electricity. So they generate all these things. So some of these things can be a certain place that they have a huge pool of water. Then there is a dam. So those are called water dam. Okay, that is a critical infrastructure for the certain countries. They use it to generate electricity for that. Okay, so that's what kind of generation. There can be a solar farm. Okay, for certain country, and then for hospital and whatever, it's not really in generation. So all these things is either deal with water or electricity. Okay, so for Singapore mainly is water, right? If you think about it, and then we also have electricity. So these are the two main part that actually goes into. One of it is your reservoir, right, which is water, right? And then electricity, we do have some form of solar farm, but we also have some other kind of electricity generation. Basically, the normal power plant that actually using burning of fuel and do that thing. Okay. Electricity, I told you about cooling down, right? But it's not just cooling down. What we are boiling the fuel here. This is the fuel, and then we will boil some water, and then become steam. And then this steam will turn some turbine. Okay, and then this turbine run, it will generate electricity. So that's how electricity is being generated. Okay, most of the time you have some fuel, you have oil, whatever, you boil water, the water will go out, right? And then you turn the turbine. And this is the typical thing. If your water falling down, of course, it will same thing. Because of the falling down way, it will turn a turbine. By water falling down, turning a turbine end of the day. Okay. Last part is the distribution. Distribution very similar to transmission. Okay. Transmission is mainly electricity and water, all these things. Distribution is after the substation, right? You want to go to individual household, right? That is distribution. Okay, for this entire portion. Okay, let's go and take a look further in detail. So a site is a process that discrete manufacturing produce a product. Okay, a site can be a physical product within a fence of enclosure. Okay, they have all these protection, physical protection. Okay, it's located at site. So typically most of the time there are people there, and there are people can support the equipment. Second one, transmission. Okay, as I mentioned, it can carry electricity, oil, gas, and water for over a long distance. Okay, it can also include railway and highway end of the day that carry goods, okay, for manufacturing facility. So a lot of these facilities are usually unmanned because there's such a long distance, right? You're not going to have in between, you're going to have whatever. The key part that we are mentioning here is the substation that may have some electrical or whatever that actually retransmission and what. It's a computerized systems. It's a computerized system, and nowadays they are connected to the network, and if they're hacked, then it becomes an issue for a lot of people. Okay, so only during maintenance that people will go and visit these places. Okay, during maintenance and operational staff will visit these things. So it is kind of issues end of the day. For example, your street lights, right? They have a long list of things. If the street light is working fine, nobody going to touch it, right? But street light can be anywhere. It's not everybody going to touch it. More and more of these street light, because they are LED. I'm talking about Singapore LED. Then, if they are having issues, then it comes out because it connects back to a grid. It may affect our power grid also. End of the day. Okay. Generation. Electrical generation, they may consist of produce energy, generate electricity. It can be also water also, right? Deals with water. Okay, such facility is such as dams, wind, and solar farm. Okay, they are remote operation, and sometimes they are publicly accessible. So sometimes we are quite careful because reservoir is publicly accessible, right? Okay, so this is one of the things that we are talking about. Okay, of course there are some other things such as chemical, hydro, wind, and solar, and nuclear. These are some of the things. Singapore, we do mechanical, we do hydro, some for hydro in some of the island, and we do some wind and solar. There's a few that we do in Singapore. Okay, those are circle. I circle one: mechanical, hydro, wind, and solar. We do in Singapore. We don't do chemical and nuclear actually. Okay, for electricity wise. Next, distribution. To deliver, as I mentioned, after the subsystem, you need to deliver the electrical system to our home and businesses. That's why I told you, this is your generator. Then you have the transmission, right? Then you have some substation. Okay, then this is your delivery. Okay, so that's the difference between your transmission and delivery end of the day. Okay, so a lot of these things are also unmanned. Okay, and then some of them people may want to do some form of remote access to it before you get to your home and all these kind of things. So Singapore quite small. Singapore don't have a lot of this, but then in US, in bigger country, they typically have quite a lot of these systems. So the end of the day can do the proper support for all these things. Okay, the key one that has a lot of these things in Singapore one, electricity is one of them because the thing is under HDB there is this distribution box and underneath all the HDBs. So those are all the rooms that actually have that. Okay, and then over there is also a lot of communication. Your water and gas not so much. Singapore mainly this part is basically electricity and comms communication. Okay, your fiber or whatever. These are the two one, and then two of them mainly comes with a lot of these comms used to be phone and then mechanical or whatever, but then end of the day becomes computerized. Okay, your fiber link, your cable modem, your ADS or whatever, and your electricity itself. Okay, so these are the two main part that is here, right? T, we don't have so much of T, as I mentioned, is the same thing, but then we do have water pipe and gas pipe. Okay, so here we'll have water and gas, okay, plus whatever these two things here. Okay, so these are some of the examples. I shall not go further. I just now mentioned quite a bit of the example already. Okay, we come to objective 5. We are going to look at different type of industrial processes and their dependencies. Okay, next we're going to look into industrial processes. So industrial processes broadly can be classified into two different kinds. First is a discrete, the second is a process. Okay, whatever that is a manufacturing process that is involved. So if you look at discrete manufacturing, it can be easily differentiated. Okay, create something that you can touch, such as a car, book, toy, furniture, or cell phone. Right? It is not continuous, so it can be start or end at any time. Okay, it involves creation, assembly, handling of individual component. It can be easily counted and measured in units. Okay, and a lot of time robots are used to or whatever system is being created to be used for discrete manufacturing. It doesn't concern a lot of in terms of your liquid portion or whatever. Most of the time it's solid Most of the time solid. Okay. Next, processes involve formulas, right? Such as a recipe, end of the day. It can include oil refinery, okay, chemical refinery, food beverages production, pulps and paper, okay, because paper is end of the day is from liquid and all this kind of stuff. Okay, it is different from discrete manufacturing. Okay, it cannot be taken apart to get back to the original component. So discrete can get back to the original component. And processes can be break into number 1, continuous, 2, batch, 3, hybrid. Okay, then we look into individual part. If it's continuous, okay, it requires to be an uninterrupted flow from start to finish end of the day. Okay, such as example, to make of chemicals. So some of the pharmaceutical component you need to be continuous process. The very obvious one is water lah. Okay, the very first is water, filtering water lah. Water may not be 100% this but then part of water is very much continuous, because at the end of the day you need to clean the water. In the same way, electricity need to be continuous, because you cannot just stop suddenly at the end of the day. Okay, electricity sometimes can or what's or not but then most of the time cannot Okay, same. They need to, when you want to do a shutdown, you need to be very careful about this thing, right? It is normally just continuous run. Okay, it will not stop unless it's caused by an emergency or equipment failure. Okay, it can be shut down for scheduled maintenance. I checked with my friend. Typically, for example, water is once a year. Okay, once per year. Okay, for the turnaround time, because sometimes you need to do maintenance, you need to also do all the necessary check. But at the same time, that's a good time when we start to do cybersecurity patch. Okay, that's one of the key things that you need to take note of. Okay, then the turnaround for this thing is to make sure that it is in a very safe operation. Okay, so availability here is very, 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 very important. Okay, and then the turnaround time can be different, right? Basically, the shutdown time can be very different. Some may be a month, some may be a year. As I mentioned, water system in Singapore is about once a year. So, ICS for this continuous one, you need to have these are some of the breakdown if you really take a look at just now what we mentioned, right? If from startup, you need to have a continuous operation. You only shut down when there is an emergency or maintenance. Okay, so that's one of the key part. Next, beside continuous, there are some things that can be a batch. You create certain thing, it's a batch, finish ready, then you move on, you close down, you do whatever maintenance, and you move on to the next one. So every phase of a batch is finished. So one phase per batch, okay, and then you will transit into the other phase of the batch itself. So it's a batch and then a batch. So most of the pharmaceutical company are actually based on batch systems, okay, and they can do batch management. So it's still better than what you call it, the continuous. The batch is always have a start time and an end time, and you can predict some form of that process and of day. Okay, so they will also have things such as record management, okay, which a lot of time is important when they are required to audit the batch process. Okay, through that actually you can look into how you can better your cybersecurity at that particular point. So this batch, how is it doing? Next batch, how is it doing? In between, do we have some regulation or not? Of course, the most easiest one is discrete end of the day, right? Okay, because you can stop anytime. This one cannot. This one have a starting point and an ending point. But then at least you have a starting point and ending point. Continuous, there's no starting point and no ending point. Once you kickstart, is only the turnaround time of there's an emergency stop. Okay. Then some of them are hybrid for example, water treatment. If you go to water treatment, right, it is a continuous process most of the time, but then partially it can be kind of can do some form of batches in between, right? But then a lot of time no not really Okay, so this is the breakdown between a batch process and a continuous process. Okay, so equipment wise, low cost. This one is very high cost, very expensive. Okay, shut down quite often. A batch can be an hour, a batch can be a day. Okay, this one is once a year. Okay, this one is rare. Okay, so that's some of the key thing Process dependency. Process may have upstream, may have downstream. Okay, the dependency create both cyber and physical security. A lot of time, both are okay. Our process are not an island; they don't stand alone by themselves. Okay, they're connected, interconnected, and process can define by any type of critical system. End of the day, whether it's communication, transport, electrical, water, okay, pharmaceutical, can be any process, can be defined by any critical infrastructure and everything. So a lot of these things are actually at the back end, because it's a computerized system, modern one. So there is a key one, which is a communication dependency. It highly depend on communication because they need to interconnect and they need to communicate with one another in order, end of the day, to function properly. Okay, so it may be as simple as an operator looking at two different screens from two different systems. Okay, two different screen and two different systems. Okay, manually to adjust the system. Okay, it may require more than two separate control systems that is networked together to share information. Those are very, very fast systems. Okay, the first one is a fine tune, very old one. This one is the modern one. So a split second, you need to get it working. So a cyber event, okay, end of the day, could create when they interrupt the critical info communication, could cause the process to fail, and end of the day, it may have an impact both upstream, whatever things that provide you, and downstream, whatever that require you to do it, and then end of the day, impact the process itself. Okay, so it is important to look at the control system from that perspective. So this is a typical process. So there may be some upstream, right? For example, the upstream of electrical system may be water, the downstream may be water again. Okay, and then because of the water is going to the electricity, of course behind down the stream it may be communication, okay, it may be transport, okay, maybe a lot of other stuff, right? And some of these things may be involved in terms of energy wise. Okay, so we kind of cover most of the objective in this particular section. Okay, so we cover all the 5 objectives here, and that is all for this particular lecture 1. Thank you very much for listening. I will see you next time. Thank you. Bye bye.